All right, this is Unit 1, Lesson 7. From Open Up Resources, we're just going to go over what they've got, what your answers should have, what you should have come up with answers for the questions. And I'm just going to go through it to make sure you've got the right understanding of what you're doing here. So in Unit 1, Lesson 7, we are looking at scale drawings. So the learning targets are right here. You can go ahead and read through those. That's what you should be able to do by the end of this unit. But so for the first one here at 7.1, it says, what is a scale drawing? So we have two images of a drawing. So this top one, it says, is a scale drawing. The second one says it isn't. So we want you to kind of just look and see what is the difference. What do you notice about the drawing here that is a scale drawing, and what's different about this that is not a scale drawing? So with the three pictures, as you can see, so this school bus, all measurements look to be the correct dimensions, all proportional as you look at the back of the bus. Same with the quarter. It looks like it's a perfect circle. That looks like an exact replica of a quarter. The size might change a little bit, but everything looks correct. And then you've got the map. You notice you've got the outline of the states, or countries, I guess. And then the roads to travel. And then they have a portion here where they've enlarged it a little bit so you can zoom in and see some of the roads that they're talking about. On the other one, you've got this bus and this quarter. They look kind of a little bit cartoony. They're not exact replicas of the original. No bus has these wavy lines in the back. They're going to be straight like on the top one. And once again, this one is not considered a scale drawing. So the thing that makes a scale drawing is that it is an exact replica of something, whatever that is. It's either larger or smaller based on the scale size or the scale factor. And all dimensions are going to be proportional. So everything changes by that scale factor. And so it should look exactly like the original, just smaller. Okay. Where these might be a drawing of these images, but they're not to scale. Okay, so they're not a scale drawing. All the lines aren't exact replicas of the actual lines of the bus, the quarter, and so on. Okay, so kind of taking this a little further, we're going to use the scale size and the scale drawing to find the actual dimensions. Okay, so you should have found a picture of a basketball court that was attached in Google Classroom. I'm going to have one filled out down below, but we're just going to go and fill this out. So it says that on that picture that the scale size is for every centimeter that represents 2 meters in actual in actual length. Okay, so it says measure the distance of the drawing that are labeled A to D. So go down here. So here's the basketball court. So A was the length, B was the width, C was the distance from hoop to hoop, and then D was the distance from the 3-point line to the sideline. And so I measured all these on the paper printout. You got 14 centimeters for the length, 7.5 for B for the width, 12.4 centimeters for the length, and 0.5 centimeters for the distance between the 3-point line and the sideline. If you printed this out, if your scale was a little different, you might have seen a little bit different measurements, and that's fine. All right, so we go back to this and we want to fill it out. So in the scale drawing, this was 14 centimeters. This was 7.5 centimeters. Hoop to hoop was 12.4 centimeters. And then the 3-point line was 0.5 centimeters. Okay. Now it talks about, once again, the scale was 1 centimeter represents 2 meters in actual length. So now, number 3, it says, how long would each measurement from the first question be on an actual basketball court? Explain or show your reasoning. Well, if we know that to the scale, 1 centimeter is equal to 2 meters, so for every centimeter, that's equal to 2 meters. So all we're going to do is take our drawing dimensions and multiply them by that scale factor of 2. So 2 times 14 is going to be is going to be 28, but now we are in meters. So meters is roughly about a yard. It's a little bigger than a yard. 7.5 times 2, that's going to be 15 meters. 12.4 times 2, that's going to be 24.8 meters. And 0.5 centimeters, that's going to be 1 meter. So now with the scale and with the drawing, we can tell the actual distance of this court. Okay, so once again, we multiplied. You multiply that drawing dimensions by scale. Okay. All right. Number 4. So now we're going to kind of work a little backwards. So on an actual basketball court, the bench area is typically 9 meters long. So in A it says, without measuring, determine how long the bench area should be on the scale drawing. Okay, so before we're going for the scale drawing to the actual dimension, so that's going to be multiplication. We're going to multiply by that scale factor. Now, if we're going to go the other way, we're going to go backwards. We're going to go from the actual dimension to our scale drawing. We need to undo that multiplication. So to undo multiplication, it would be division. So you are going to divide that actual dimension by 2. So 9 divided by 2 is going to equal 4.5. So on this drawing, we should see that it measures about 4.5 centimeters. And when you go down, I measured it, and sure enough, it is 4.5 centimeters. So that does match and follow that scale. Okay, and so once again, if you're going from the drawing dimension to the actual, you're going to multiply. If you're going to go from the actual dimension to the drawing dimension, you need to divide or multiply by the scale's reciprocal. So if it was 2, that's the same as 2 over 1. The reciprocal of this, I'm going to say recip, is going to be this flipped. So that becomes 1/2. Okay, so you're dividing by 2 or you're multiplying by 1/2. All right, 7.3. So once again, you're given a scale. This time the scale's right here. You have to measure and see what that correlates to in actual dimensions. When you do this, this length right here becomes, this becomes 1 centimeter. So what our scale is telling us that every 1 centimeter is equal to 100 meters. Okay, so now we take our ruler, we measure each height of these and answer the questions below. So when we measure the Willis Tower, it's about 5.4 centimeters. This Great Pyramid is about 1.4 centimeters. The Eiffel Tower is about 2.8, almost 3 centimeters. Students have been getting 3. When I measured, I had right around 2.8. Okay, and the Burj Khalifa, that one measures out to be 8 centimeters. Okay, so now that we know the measurements of all of these, we can answer the questions below. So about how tall is the actual Willis Tower? Well, if it is 5.4 centimeters, and we know that 1 centimeter is equal to 100, we're going to multiply our measurement by 100. So, oops. So 100 times 5.4 equals 540. All right, the Great Pyramid. So we're going to do the same thing. We multiply what we measured by 100. So that was 1.4 times 100 equals 140. Okay, we're going to do the same thing for this next question, but this one is comparing two measurements. So it says about how much taller is the Burj Khalifa than the Eiffel Tower. Explain or show your reasoning. So we're going to look at our actual dimensions. So we know the Burj Khalifa is 8 centimeters in this drawing. And so we're going to multiply 8 times 100 to get 800 meters. We're going to do the same thing for the Eiffel Tower. 2.8 times 100 equals 280. So now all we need to do is find the difference. When we're finding the difference, that's just subtraction. So 800 minus 280 is equal to 520. And so there now we can tell the difference in the height. Okay, number 3, it says measure the line segment that shows the scale to the nearest tenth of a centimeter. Express the scale of the drawing using numbers and words. So I already mentioned that. We measured it was 1 centimeter, so therefore 1 centimeter is equal to 100 meters of actual distance. Okay, and just this last thing to think about. So it says the tallest mountain in the United States is Mount Denali in Alaska, which is about 6,190 meters tall. If this mountain were shown on the scale drawing, how would its height compare to the height of the structures? Explain or show your reasoning. So, to find the drawing height, we just divide this by 100. So if you take 6190 and divide it by 100, you're just moving the decimal place 2 back, so that'd be 61.9. And now 61.9 obviously is over here on the other side of the Burj Khalifa. This is a lot taller than all these buildings. 61, that's almost 8 times taller than the Burj Khalifa building. All right, so that is looking at scale drawings and how to use scale drawings and their scale to find actual dimension, or give an actual dimension, how to use the scale to find the drawing dimension.